Here is a simplified view of the magnetic environment around Jupiter and its four largest moons, Io, Europa, Ganymede, and Callisto. In reality, the interactions are extremely variable and complex. ESA's Jupiter Icy Moons Explorer, JUICE, will investigate the magnetic environment in great detail, exploring the invisible connections between the moons and the giant planet to understand more about the interplay of this intensively dynamic system. The giant planet's aurorae are displayed as a blue ring around the north and south polar regions, and its magnetic field lines are shown in dark purple throughout. The animation then moves through the key elements of the magnetic field situation at each of the moons. Callisto, the outermost of the four large moons, is the first to be seen, showing the geometry of the magnetic field created within the moon's putative subsurface ocean as the moon moves through Jupiter's magnetic field. The next sequence shows the Ganymede's magnetic environment, which is a combination of an induced and internal magnetic field. Ganymede is unique in the solar system in that it is the only moon known to generate its own magnetic field, which has complex interactions with Jupiter's own vast magnetic field. Ganymede's auroral ovals are illustrated in blue rings in the mid-northern and southern latitudes. They are influenced by Jupiter's magnetic field as well as the moon's buried ocean. Europa is represented next, with its magnetic field created within its subsurface ocean. Io, the innermost of the four large moons, is illustrated with vertical magnetic field lines connecting to Jupiter. Io is a volcanic moon, and its thin sulfur dioxide atmosphere generates an ionized plasma torus around Jupiter, seen as the hazy yellow ring. Zooming out, the final sequence shows Jupiter and its large moons, as well as the Io torus, created by the ionization of the volcanic moon's atmosphere. Jupiter and its four large moons are often considered as an archetype for a solar system in their own right. Thus JUICE's investigations of the moons and their interactions with Jupiter will provide unique insight into the numerous exoplanet systems that have been discovered elsewhere in the universe. Jupiter is surrounded by an enormous magnetic field called the magnetosphere, which has 1,000,000 times the volume of Earth's magnetosphere. Charged particles are trapped in the magnetosphere and form intense radiation belts. Why does Jupiter have the highest magnetic field? Jupiter's outer core is also thought to be responsible for its enormous magnetic field, though it is liquid hydrogen crushed by intense pressure into a metallic form that generates the magnetism rather than iron compounds. Jupiter hosts the most powerful magnetic field of all the planets in our solar system, with a field close to 20,000 times stronger than Earth. Jupiter has a large, complex, and intense magnetic field that is thought to arise from electrical currents in the rapidly spinning metallic hydrogen interior. Jupiter's diameter is over 11 times that of Earth, but its magnetic field is a massive 20,000 times stronger, making it absolutely huge, and unrivaled in complexity. Jupiter is 628 million kilometers away from Earth. It takes better care of the Earth than us. Jupiter has saved our planet multiple times, attracting the giant chunks of rocks hurtling through space, keeping the inner planets safe from comets and asteroids that could destroy them. It spins so fast that a day on Jupiter lasts only 10 hours. At 28,000 miles per hour, it's the fastest spinning planet in the solar system. That's about 2.8 times faster than Earth. There is no solid surface to land on Jupiter. The artistic cloud tops are just 50 kilometers deep. The magnetic field of Jupiter is about 14 times stronger than that of Earth. So far, 8 spacecraft have visited the gas giant, and only 2 have orbited it. Jupiter's interior holds the secrets of the early solar system. NASA's Juno mission has provided the first view of the dynamo, or engine, powering Jupiter's magnetic field. The new global portrait reveals unexpected irregularities and regions of surprising magnetic field intensity, including one already playfully known as the Great Blue Spot. Red areas show where magnetic field lines emerge from the planet, while blue areas show where they return. As Juno continues its mission, it will improve our understanding of Jupiter's complex magnetic environment.